Hello students of class 10 Advanced Mathematics, page number 55, Properties of Complex Numbers. So you see property number 1, if a plus ib is equals to 0, then a is equal to 0 and b is equals to 0. Okay. So you see first property, what it is, if a plus ib is equals to 0, then a is equals to 0 and b is equals to 0. Next, equality of complex number. Two complex numbers are equal if and only two complex numbers are equal if only the real and the imaginary parts of one are respectively equal to the real and the imaginary parts of the other. So you see there are two complex numbers here. First it is z1 and the another it is z2. So in here you see, let z1 is equals to a plus ib and z2 is equals to c plus id be two complex numbers such that a is equal to c and b is equal to d, then z1 is equals to a plus ib is equals to c plus id is equals to z2. That means property number 2, it is what saying, if let's say there is one complex number z1 which is a plus ib and there is another complex number z2 which is c plus id. Now if z1 is equals to z2, if these two complex numbers are equal, z1 equals to z2, a plus ib is equals to c plus id, these two complex numbers, if they are equal, then I can say that a is equals to real part equal, I can say, and imaginary part equal, I can say. And conversely, if real part equal there, imaginary part equal there, then conversely I can say that a plus ib it is equals to c plus id. Okay, then I can say that z1 is equals to z2. So property number 2 is the main important thing. It is that if the two complex numbers they are equal, then I can directly equate the real part I can equate, the imaginary part I can equate. Okay, you will learn when I will solve the examples, you will learn this property nicely. So next, these are closure property, commutative property, associative property, distributive property, identity property, inverse property. Everything we will learn. Okay, everything we will learn when we will solve problems. So first you see example number 1. Let's see example number 1. You see, if x plus iy it is equals to 3, sorry, in here it is saying, if x plus iy plus 3 it is equals to y plus 3xi, find x and y. Now saying that these two complex numbers they are equal. So solution, I will write that x plus 3, okay, this is the real part, x plus 3 it is the real part, okay, plus iy, this is equals to y plus 4xi. Okay, since these two complex numbers they are equal, so therefore I can say that x plus 3 it is equals to y and y is equals to 4x. Real part equal, imaginary part equal. Okay, so therefore here I will get x minus y is equals to 3, y value is 4x given, put it in here, x minus 4x is equals to 3, minus 3x is equals to 3, x is equals to 3 by minus 3, so x is equals to minus 1. This minus 1 you put it in there, y is equals to 4 into minus 1, y is equals to minus 4. Therefore x equals to minus 1, y equals to minus 4. This is our answer. Okay. Now next you see example number 2. I hope you have understood this. X plus y equals to, in here you can write and y is equals to. So x equals to -1 and y is equals to -4. Next you see, next again example 2. Example 2, it is saying that find the additive inverse of z, which is equals to -4 plus 5i. Find the additive inverse of z. Okay. So additive inverse, the additive inverse of z, the additive inverse of z is -z. Okay. So z is equals to -4 plus 5i. So minus z is equals to -4 plus 5i minus z is equals to +4 minus 5i. No need to write this plus sign. 4 minus 5i. So this is your answer. Find the additive inverse of z. Okay, so the additive inverse of z is -z. So this is z is equals to -4 plus 5i. Both side minus you do. Minus z is equals to, so minus z is equals to 4 minus 5i. Okay. Next you see example 3 here. Example 3, for the real numbers alpha comma beta comma a and b, if alpha plus I beta to the whole power 1 by 3 it is equals to a plus ib, then so that alpha by a plus beta by b is equals to 4 into a square minus b square. Okay, so here this is given that alpha plus I beta 1 by 3. This is example number 3. It is saying that I 1 by 3 is equals to a plus ib. So what I can do here is that both side I can cube it. Yes, cubing both side. Alpha plus I beta is equals to a plus ib the whole cube. You can write here cubing both side. Okay, cubing both side. So alpha plus I beta is equals to, break this into formula, a cube plus b cube plus 3aib a plus ib. This is alpha plus I beta is equals to a cube plus I cube b cube plus this one, if I multiply 3a square ib plus 3a ib the whole square. So alpha plus I beta is equals to a cube. I cube, its value is I, so I b cube plus 3a square ib, and this becomes plus 3a I square b square. So alpha plus I beta is equals to a cube plus I b cube plus 3a square ib minus 3ab square. Now alpha plus I beta is equals to, real part you bring it one side, a cube minus 3ab square, plus from these two I common you take b cube plus 3a square b. So real part equate, alpha is equals to a cube minus 3ab square, and imaginary part equate we will do. So beta is equals to b cube plus 3a square b. Okay, so what I have to find here for the real numbers. Okay, so that alpha by a plus beta by b is equals to 4. Okay, so alpha and beta value I got. Now I will take LHS. Alpha by a plus beta by b is equals to, I will get a cube minus 3ab square by a plus plus this I will get b cube plus 3a square b by b. In here a common you take, a square minus 3b the whole square by a plus b common you take, b square plus 3a square by b. So a cut, a square minus 3b square plus bb cut b square plus 3a square. So this is a square plus 3a square plus a square, 4a square, and this I will get minus 2b square. So from here, okay, in here, did I made any mistake here? Did I made any mistake? So this was a plus ib the whole square, a whole cube. So did I let me see, I cube value, I cube, I think I made a mistake here. I cube value, oh sorry, I cube value, it is minus I, not I. Okay, I cube value, it is minus I, it is not I. In here just I made a mistake here. This is it will be minus I. Okay, it will be minus I, it will be minus I. So this, it will be these two, I have I common, I have taken, so minus in here, it will minus, it will remain. So in here it will remain minus, it will remain. Okay, this is a small mistake I have done. So this is b cancel out, this will be minus, okay, minus b square. So this, it will be it will minus 3b square minus b square, 4b square it will become. So is equals to, from here 4 if I common take, I will get a square minus b square, which is equals to RHS. This one our proved. Understand? That one I have to prove. Alpha by a plus beta by b is equal to 4, a square minus b square. That one only I have done here. Alpha by a plus beta by b is equals to 4, a square minus b square. So what I have done, I am telling you for one more time. This is our, it is given. Cubing both side I did. This is formula, I break it. Okay. This is a plus b the whole, a plus ib the whole cube, or this is, you can say a plus b the whole cube formula. And so a cube plus ib the whole cube plus 3aib, a plus ib, you this multiply you do, and a cube value, you remember, it is not plus I, it is minus I. Understand? It is minus I. So this I will get, okay, this is I square value is minus 1, so minus 3ab the whole square I will get. Now real part you bring it one side, real part or you bring it one side, a cube minus 3ab square plus I minus b cube plus 3a square b I will get. So now real part equate, imaginary part equate. So now I will take LHS, alpha by a plus beta by b. Alpha value I will put it, beta value I will put it, and ultimately this one you can keep it inside a bracket. Ultimately from a common I have taken, b common I have taken, a cut, b cut. This I will get, this is 4a square minus 4b square. From there 4 common take, this is equals to RHS. Understand? Next you see conjugate complex number. Suppose z is equals to x plus iy, where x, y belongs to R and I is equals to root over minus 1 be a complex number. Then the complex number x minus iy is called the conjugate complex, or simply the conjugate of the number z is equals to x plus iy. The conjugate of z is symbolically denoted by z bar. For z is equals to x plus iy, we get z bar is equal to conjugate of z, and it is equals to x minus iy. Conversely, if z is equals to x minus iy, then its conjugate is z bar equals to x plus iy. Thus, by changing the sign, plus changes to minus and minus changes to plus of the imaginary parts of the complex number, we get the conjugate of that number. For example, if z is equals to 3 minus 4i, then z bar will be 3 plus 4i. If z is equals to 5i, then z bar will be minus 5i. Okay. Next, properties of conjugate numbers. If z is a real number, then z bar, it is equals to z. For example, if z is equals to 5, then z bar is 5. If z is equals to 0, then z bar will be 0 only, etc. If z is a pure imaginary number, then z bar is equals to minus z. let Z is equals to IP, where P belongs to R, then Z bar will be minus IP. Okay, is equals to minus bracket IP is equals to minus Z. The conjugate of a complex number is the number again. So Z bar again bar, it will be Z only. Let Z is equals to A plus IB, then Z bar it will be A minus IB. Now Z bar again bar is equals to conjugate of Z bar is conjugate of A minus IB, which becomes A plus IB is equals to Z. The sum of the complex number with its conjugate is a real number, because if Z is A plus IB and Z bar is A minus IB, then Z plus Z bar, it will be twice A. Understand? It will be a real number. Imaginary part will cancel out and go. Next, Z plus Z bar is equals to twice A. We can also write it as Z plus Z bar. It is equals to real part of Z. Understand? RE Z. Z minus Z bar, it becomes 2I imaginary Z. Okay, I am Z. Next, you see the product of a complex number with its conjugate is a real number. If Z is A plus IB, Z bar will be A minus IB. If you take out the product, you will get A square plus B square, which is a real number. Understand? So Z into Z bar, it is equals to A square plus B square is equals to REZ the whole square plus IMZ the whole square. Real part square plus imaginary part square. Understand? Now we will study, you see, modulus of a complex number. Z is equals to A plus IB, then modulus of Z, which is Z, this one I will have to give, modulus of Z, it is equals to root over A square plus B square. So this is modulus Z the whole square, it becomes A square plus B square. Therefore, the above property in D is stated as Z into Z bar, it is modulus Z the whole square. Okay, a few other properties are stated below which can be proved easily by the student in consultation with the teachers. Z1 plus Z2 whole bar, it becomes Z1 bar plus Z2 bar. Z1 minus Z2 whole bar there, then it becomes Z1 bar minus Z2 bar. Z1 into Z2 whole bar there, then it becomes Z1 bar into Z2 bar. And Z1 by Z2 the whole bar there, then it becomes Z1 bar by Z2 bar. Understand? So in here, first of all, you see conjugate of complex number. Understand? Conjugate you see in here conjugate complex number. So let Z is equals to A plus IB. Let Z, it is a complex number, okay, and it is A plus IB. The complex number is A plus IB. Then the conjugate of Z, I write it as Z bar. The conjugate of Z bar is what? It is the conjugate of Z. It becomes Z bar is equals to A minus IB, or you can say the conjugate of the complex number A plus IB. The conjugate of the complex number A plus IB is A minus IB. Understand? For example, if Z is equals to 3 minus 4i there, its Z bar will be 3 plus 4i. If Z is equals to 5i there, its conjugate will be minus 5i. Understand? So, if Z is a real number, okay, that means the complex number Z is a real number. For example, like Z is equals to 5. Imaginary part is 0. Z is equals to 5. Z bar will be 5 only. Okay. Next, saying that if Z is pure imaginary, Z is pure imaginary. For example, like Z is equals to 5i. Pure imaginary, real part 0 there. Then Z bar will be minus 5. Understand? Z bar will be minus 5. Or if I say that Z is equals to 6i, then Z bar will be minus 6i. Understand? So therefore, if Z is pure imaginary, then conjugate of Z, it is equals to minus Z, I can say. Understand? Conjugate of Z, it is equals to minus Z. Okay. Now, conjugate of the conjugate of a complex number. That means if I say that conjugate, for example, Z is equals to A plus IB, its conjugate will be what? A minus IB. Now the conjugate of Z bar, which I can say Z bar again bar, the conjugate of Z bar, it becomes A plus IB. Understand? So therefore I can say that you see the conjugate of a complex number is the number again. The number was A plus IB, its conjugate is A minus IB. Now the conjugate of this conjugate, it becomes the number again. Okay, and next it is the complex number Z plus its conjugate, it is equals to whatever you will get, this will be a real number. Okay, this will be a real number. And Z minus its conjugate, it becomes twice I imaginary I am Z. Okay, for example, you see here real number means Z plus Z conjugate, it is equals to a real number, or you can say it is equals to REZ. You will get the real part of Z. Okay, this real part of Z, and then Z minus Z bar, this you will get is equals to twice I am Z. You will get twice I am Z, the imaginary part of Z. So if Z is equals to, you see in here, Z is equals to A plus IB, then Z conjugate will be A minus IB, and Z minus Z bar, if you solve it, you will get 2IB. So 2I imaginary Z, that means 2I, and you will get the imaginary part of Z. In here, actually, instead of writing 2AI is equals to REZ, actually they should have written here twice REZ. Yes, let's check it. Let Z is equals to 5 plus 3I, then Z bar will be 5 minus 3I. So Z plus Z bar is equals to 5 plus 3I plus 5 minus 3I. So this becomes 10, which is equals to 2 into 5. Yes, and you can write 2 imaginary part of Z, because 2 into 5 is what? 5 is the imaginary part of 2 into REZ, because 5 is the real part of Z. Yes, 2 into REZ. So Z plus Z bar, you will get 2 REZ, and Z minus Z bar, you will get 2I imaginary I am Z, imaginary part of Z. Understand? And then Z into Z bar, this let me write it nicely. Z into Z bar, Z into Z bar is equals to, you will get, you can write this as REZ the whole square plus IMZ the whole square. Real part square plus imaginary part square. Understand? And next, it is one thing it is saying here, that you see so this one, Z into Z bar, you can write it as modulus Z the whole square also you can write. Understand? Modulus Z the whole square also you can write, because let's say Z is equals to A plus IB, then modulus of Z becomes root over A square plus b square. So modulus z the whole square, it becomes a square plus b square, which is equals to z into z bar. So z into z bar, you can write this, or you can write modulus z the whole square also you can write. And next few properties are given, that z1 plus z2 whole bar there, then z1 bar plus z2 bar becomes z1 minus z2 the whole bar there, then z1 bar minus z2 bar becomes, and z1 into z2 bar there, then z1 bar into z2 bar becomes, and z1 by z2 the whole bar there, then z1 bar by z2 bar becomes. These are some properties given. Okay, so next we will start with example 1. Okay, so example 1, you see, find the conjugate number A. It is given 2 plus 3i 3 minus 4i. Understand? So in here, solution, you see, so first of all, in here I can write let z is equals to 2 plus 3i and 3 minus 4i. First of all, let's multiply it and bring it to a plus ib form. Okay, let's multiply and let's bring it to a plus ib form. 6 minus 4 to the 8i plus 9i minus 12i square. So z is equals to 6 plus 1 plus 12. Z is equals to 18 plus I. Understand? Z is equals to 18 plus I. So therefore, conjugate of Z is equals to Z bar is equals to 18 minus I. Understand? Conjugate of Z, which is equals to Z bar, and this will be is equals to 18 minus I. This is your answer. Okay, next again it is given number B, it is given the 3 plus I by 2 plus 5i. So this one, what I can do, 3 plus I, 2 plus 5i, this one I can do 2 minus 5i, 2 minus 5i. So this first of all, 1 minute in here, first of all I will take let. Okay, let z is equals to 3 plus I, 2 plus 5i. So z is equals to 3 plus I by 2 plus 5i. This becomes 2 minus 5i, 2 minus 5i. This one 3, 2 minus 5i plus I, 2 minus 5i. By this becomes 4 minus 25i square. Okay, a square, a plus b into a minus b formula, 2 square 4 become minus 5i the whole square, 5i square, 25i square becomes, so this is 6 minus 15i plus 2i minus 5i square, 4 plus 25, which is equals to 6. This becomes minus 13i plus 5 by 29. So 11 minus 13i by 29. So z. Let me write this in a plus ib form. So your this becomes z is equals to z is equals to 11 by 29 minus 13i by 29. So therefore z bar, which is the conjugate of z, it becomes 11 by 29 plus 13i by 29. This is your answer. Okay. Next you see, next example 2, it is saying that find the multiplicative inverse of z. Example 2, it is saying that find the multiplicative multiplicative inverse of Z is equals to 2 minus 3i. Find the multiplicative inverse of Z. So Z is equals to 2 minus 3i. So multiplicative inverse of Z, multiplicative inverse of Z, which is equals to 1 by Z, equals to 1 by 2 minus 3i. So equals to 1 minus 2 by 3i. So 1 by Z is equals to 1 by 2 minus 3i. This what I will do, 1 by Z is equals to 1 by 2 minus 3i. Let me do this in this step only. So this one, 2 plus 3i, both numerator and denominator I will multiply it by 2 plus 3i. This is minus there, so I will use 2 plus 3i. Okay, both numerator and denominator I will multiply it by 2 plus 3i. If it was 2 plus 3i, then I would have multiplied by 2 minus 3i, both numerator and denominator. So this is ultimately, this one I will get 2 plus 3i, and denominator it will become 4 minus 9i square. So 1 by Z is equals to 2 plus 3i, 4 plus 9. So 1 by Z is equals to 2 plus 3i, 4 plus 9, it becomes 13. So 1 by Z is equals to 2 by 13 plus 3 by 13. I plus, it means a plus ib form I am writing, 2 by 13 plus, this is a plus ib, I 3 by 13. Okay, this is the multiplicative inverse of Z. Understand? Or you can do it this way also. Z is equals to 2 plus 3i. So therefore Z inverse, understand? Z inverse, it becomes 1 by Z, which is equals to 1 by 2 minus 3i. Okay, this one you do in this step, and ultimately you will get this one. Okay, so next again you see example 3. If you have any doubt regarding any question, you please write it in the comment section. Okay, Z is equals to 3 plus 4i by 5i, then find Z into Z bar. Okay, then find Z into Z bar. So solution here, it is given that if Z is equals to 3 plus 4i by 5i, then find Z. So first of all, Z is equals to 3 plus 4i by 5i, it is given. Okay, so this one, Z is equals to, I can write 3 by 5i plus 4i by 5i. So Z is equals to, you see this becomes 4 by 5 plus 3i by 5i square. Okay, both side I multiply, doing this I will get. So Z is equals to 4 by 5, this is minus 1 become, that means minus 5 become, minus will go to the numerator, then I can write like that, 4 by 5 minus 3i by 5. Okay, so therefore Z bar, it will be 4 by 5 plus 3i by 5 I will get. Understand? So Z into Z bar is equals to 4 by 5 minus 3i by 5 into 4 by 5 plus 3i by 5 I will get, which is a plus b into a minus b formula. So 4 by 5 the whole square minus 3i by 5 the whole square. This I will get 16 by 25 minus 9i square by 25, which I will get 16 by 25 minus, it will become plus because 9i square there, I square value is minus 1. So 9 into minus 1, you will get plus 9 by 25 you will get. So ultimately this one, if you take the LCM here, you will get 25 only. This is 16 plus 9, 16 plus 9, 17, 18, 19, 20, 21, 22, 23, 24, 25 only you will get. So 25 by 25 we will get, which is equals to 1. Understand? So therefore Z into Z bar is equals to 1 solved. Understand? You can do in this way. I hope you have understood. Next, again, you see example number it is given 4. Example number 4, it is given if saying that if x plus iy it is equals to a minus I by a plus I, then prove that x square plus y square it is equals to 1. Now solution. Now this is, it is your given that x plus iy is equals to a minus I by a plus I. It is given it to you. I have to prove that this is equals to 1. Okay. So now in here, okay. So this one you see x plus iy is equals to a minus I by a plus I. Multiply both sides by a minus I, a minus I. This you will get is equals to a minus I the whole square by a square minus I square. A square plus I square minus 2ai by a square plus 1 I will get. Okay, a square plus 1 I will get, because this will be minus 1 minus into minus plus 1 you will get. So this again it is a square minus 1 minus 2ai by a square minus 1. You break this a square minus 1 in here minus 1. This is plus 1. A square minus 1 by a square plus 1, and this is plus I minus 2a by a square plus 1. I'm writing it in the form of a plus ib form. Understand? So in here what I got, x plus iy, x plus iy, x plus iy, and x plus iy. Now we already know that if two complex numbers are equal, then real part, and imaginary part, I can equate them. So therefore from here x is equals to this I will write, and y is equals to this I will write. So x is equals to a square minus 1 by a square plus 1, and y is equals to minus twice a square plus 1 I will write. Understand? So x is equals to this I got, and y is equals to this I got. Now I will do x square I will do. So a square minus 1 by a square plus 1 the whole square. So x square you will get a square minus 1 the whole square by a square plus 1 the whole square. Okay. This is your equation number 1, and y is equals to minus twice a by a square plus 1 there. So y square is equals to minus twice a by a square plus 1 the whole square there. So therefore y square is equals to, I will get 4a square by a square minus a square plus 1 the whole square I will get. This is our equation 2 I will get. Understanding? This is our equation 2 I will get. So now what I will do, I will do equation 1 plus 2 I will do. Okay, equation 1 plus 2 I will do. 1 plus 2 I will do. Now you see, so left hand side plus x square plus y square is equal to a square minus 1 the whole square by a square plus 1 the whole square plus 4a square by a square plus 1 the whole square. You will get denominator same there, so you will get a square plus 1 the whole square, a square minus 1 the whole square plus 4a square. So this one you break it into formula, a to the power 4 plus 1 minus twice a square plus 4a square by a square plus 1 the whole square you will get. So this is, you will get a4 plus 1 plus twice a square by a square plus 1 the whole square you will get. If you look at this nicely, you will get, this is the formula of a square plus 1 the whole square. Understand? If you look at this nicely, you will get a square plus 1 the whole square by a square plus 1 the whole square. You cut it, is equals to 1 you will get. Understand? So x square plus y square is equals to what you got? 1 you got. This is the answer. You can write, therefore x square plus y square is equals to 1. Exercise 2.2, question number 1. Determine the conjugate and reciprocal or multiplicative inverse of each of the following complex numbers. Determine the conjugate and reciprocal. So first of all, it is given minus I. I will take let Z is equals to minus I. So Z bar, which is the conjugate of Z, it will become I, and 1 by Z, which is the reciprocal of Z, it becomes 1 by minus I. So if I numerator and denominator both side I will multiply it by I, so I will get I by minus I square. So this becomes I by minus into minus 1, so it becomes I. Okay, next again, number B, it is given I, so let Z is equals to I. So Z bar, which is the conjugate of Z, it becomes minus I, and 1 by Z, it is equals to 1 by I, which becomes I by I square, I by minus 1 minus I. Okay. Next again, 2 plus I, let Z is equals to 2 plus I, then Z bar, it becomes 2 minus I, and 1 by Z, it becomes 1 by 2 plus I. So 2 plus I into 2 minus I, 2 minus I, 2 minus I by 4 minus I square, 2 minus I, 4 plus 1, 2 minus I by 5, 2 by 5 plus I into minus 1 by 5, A plus IB form. Okay. Next again. So D and E you try to do by yourself. If you get any problem or doubt, you can write it in the comment section. We will go to type 2. So type 2, it is expressed in A plus IB form. Expressed in A plus IB form. 1 by 1 plus I the whole cube. So one by, let's break it into formula, 1 cube plus I cube plus 3I 1 plus I, 1 I cube becomes minus I plus 3I plus 3I square, 1 by 1 minus I plus 3I, this becomes minus 3, 1 by 1 minus 3, it becomes minus 2, and this becomes plus 2I. So now 1 into minus 2I by minus 2 plus 2I into minus 2I. So minus 2I by, this becomes minus 2 the whole square minus 2I the whole square, A plus B into A minus B formula. Next is equals to, I will get minus 2I by 4 minus 4I square minus 2I by 4 plus 4 minus 2I by 8 minus 2 by 8 plus I minus 2 by 8, A plus IB form. So ultimately you can write in here minus 1 by 4 plus I minus 1 by 4. This is your A plus IB form. Let us check the back answer. exercise 2.2. Exercise 2.2, question number 2, number 1, you see minus 1 by 4 minus 1 by 4 I. Okay, so this thing you can a plus ib form I have to write, so you can keep it in this way, no problem. Okay, so first of all, in here what I did, first of all I broke 1 plus I the whole cube in formula. I got this, and then both numerator and denominator are multiplied by minus 2 minus 2i minus 2 minus 2i. Okay, and after that I got this, the denominator I wrote minus 2 by 8 plus I minus 2 by 8. So if I cut it, I will get minus 1 by 4 plus I minus, this is in the form of a plus ib form. Okay. Type 2, number 2, 1 minus I by 1 plus I. So again I have to express this in a plus ib form. 1 minus I minus 1 by I plus 1. So both side I minus 1, I minus 1, sorry, I will multiply 2. So this becomes I minus 1 the whole square by I square minus 1 square. This I will break it into formula I square plus 1 minus twice I by minus 1 minus 1 minus 1 plus 1 minus 2i by minus 2. So this ultimately I will get minus 2i by minus 2, which is I. So this I can write as 0 plus I dot 1. This is a plus ib form. Okay. Next again, number 3, 1 minus I by 1 plus I the whole square. So again this one it becomes 1 minus I the whole square by okay, first of all let us do in this way. Square. Okay, let's try this. 1 minus I the whole square by 1 plus I the whole square. 1 square plus I square minus 2i by 1 square plus I square plus 2i. So 1 minus 1 minus 2i by 1 minus 1 plus 2i. So minus, sorry, okay, minus or plus by 2i. So this becomes minus 1. So this I can write as minus 1 plus I dot 0. Okay, this is a plus ib form. Next again you see number 4, 1 plus I the whole square minus 2 plus I the whole square. So this again you see I break it into formula 1 square plus I square plus 2i minus 2 square plus I square plus 2 into 2i. So this becomes 1 minus 1 plus 2i minus 4 minus 1 plus 4i. So this becomes 2i minus 4 plus 3 plus 4i. 2i minus 3 minus 4i minus 2i minus 3. So this I can write as minus 3 plus I minus 2. This is again a plus ib form. Number 4, 3 plus 4i, 12 minus 5i. So this becomes 3, 12 minus 5i plus 4i, 12 minus 5i. I multiply done. So this it becomes 36 minus 15i plus this becomes 12 into 4 to the 8, 48. 48i minus 20i square. So this is again, it becomes 36. 48 minus 15, 3 plus 33i plus 20, because I square is minus 1. So 20 minus 20 into minus 1, it becomes plus 20. So now 36 plus 20, I will get 56 plus 33i. This is again a plus ib form. Okay, a plus ib form. So next it is there number 6 and 7. You try to do by yourself. Next again number 3 number a. If z1 is equals to 1 plus I and z2 is equals to 1 minus I, then then find z1 by z2 and z1 bar by z2 bar. So z1 is equals to 1 plus I and z2 is equals to 1 minus I. Therefore z1 by z2, it will be 1 plus I by 1 minus I. So this I will do 1 plus I, 1 minus I, this is minus there, 1 minus I there, so I will multiply it by 1 plus I, both side. So this becomes 1 plus I the whole square, 1 square minus I square. Break it into formula, 1 square plus I square plus twice I by 1 plus 1 minus I square, it becomes plus 1. 1 minus 1 plus twice I by 2. So twice I by 2, this becomes I. Okay. And next it is saying that since z1 is equals to 1 plus I, therefore z1 bar, it will be 1 minus I. And since z2 is equals to 1 minus I, therefore z2 bar, it will be 1 plus I. Now z1 bar by z2 bar, this becomes 1 minus I by 1 plus I. So you see in the denominator it is 1 plus I there, so both side 1 minus I will multiply it by 1 minus I, 1 minus I, 1 minus I the whole square, and this becomes 1 square minus I square. This break it into formula, 1 square plus I square minus twice I by 1 plus 1. So this becomes 1 minus 1 minus twice I by 2. So I am doing this in here. I'm writing one more time, 1 minus I minus twice I by 2. So this it will become 0. So minus twice I by 2, it becomes minus I. Okay. So this is, you see, if you want you can write it in a plus ib form. So this one 0 plus I dot 1, a plus ib form, and this is also you can write in a plus ib form, 0 plus I into minus 1, a plus ib form. Okay. Next. Next number 3, number B. If z1 is equal to this, z2 is equal to this, then find the following. z1 into z2, z1 bar into z2 bar, z1 by z2, z1 bar by z2 bar, and z1 into z2 bar. Okay, so in here, first of all, it is given that z1 is equals to 7 plus 3i given, and z2 is equals to 3i minus 7 given. So first of all I will find z1 into z2. So 7 plus 3i into this, I can write it in this way, minus 7 plus 3i. Okay, 3i minus 7 or minus 7 plus 3i. Let's multiply it. Okay, if this thing I write as 3i plus 7 and this thing becomes 3i minus 7, then a square minus b square formula directly I can say. Okay, no problem. In here let me multiply it. Minus 7 plus 3i plus 3i minus 7 plus 3i. So this is minus 49 plus 3 7 are 21i plus this becomes minus 21i plus 9i squared. So this becomes minus 49 plus 21i minus 21i minus 9. So this and this it will cancel out. Minus 9 minus 49 plus 9, 9 to the 18, 5 I will get is equals to 58 I will get. Minus 58 I will get. Okay, minus 58 I will get. So next it is your, I have to find Z1 bar into Z2 bar. So Z1 is 7 plus 3i. So Z1 bar it will be 7 minus 3i into Z2 it is you see this is equals to, I can write minus 7 plus 3i equals to minus 7 plus 3i. So Z2 it is minus 7 plus 3i. So Z2 bar it will be minus 7 minus 3i. So now again if I multiply it, okay, let's do one thing here. Let's take minus common from here. Let's take minus common. So minus it becomes 7 minus 3i, 7 plus 3i. Okay, so minus this becomes 7 square minus 3i the whole square, a plus b into a minus b formula, minus 49 minus 9i square minus 49 plus 9, 49 plus I will get 58. So ultimately I will get minus 58. This is my answer. Next again Z1 by Z2 we will do. Z1 by Z2, 7 plus 3i, Z2 it is minus 7 plus 3i. So in here what I can do is 7 plus 3i, in here plus there, so I will multiply both sides. Minus 7 plus 3i, I will multiply it by minus 7 minus 3i, minus 7 minus 3i. So this is again, let's take minus common here. Minus 7 plus 3i, 7 7 plus 3i. If I take minus common, I will get 7 plus 3i only by this again minus 7 the whole square minus 3i the whole square. So this becomes minus 7 plus 3i the whole square by 49 minus 9i square. So this minus 7 square plus 3i the whole square plus 2 into 7 into 3i by 49 plus 9. So this ultimately minus 49 plus 9i square plus 3 to the 6, 6 7 is 42, 42i by 58 I will get. So this minus it is in the numerator. So minus 49 minus 9 plus 42i by 58. This 49 I will get 40 plus 42i by 58. So in here you can take okay, you can take 2 common here. 2, you will get this 20 plus 21i by 58. This and this if you cut, you will get 29. So ultimately you are getting here minus 20 plus 21i by 29. So this one ultimately you will get is equals to minus 20 by 29 minus 21i by 29. This is the answer you will get. So next to Z1 bar by Z2 bar and Z1 into Z2 bar you try to do by yourself. Okay. Next we will go to question number 4. You try to do by yourself. If you're not able, you please write it in the comment section. Or if you have any doubt, you write it in the comment section. Z1 is equals to 2 plus 3i and Z2 is equals to 1 minus 2i. Then verify the following. Z1 plus Z2 bar, this is equals to Z1 bar plus Z2 bar. This I have to verify here. So first of all in here I will take Z1 plus Z2 bar. This will be is equals to, okay, first of all let us find Z1 plus Z2. So this it will be is equals to 2 plus 3i plus 1 minus 2i. So this is equals to, it becomes 2 plus 3i plus 1 minus 2i. This one 2 plus 1 it becomes 3 and plus 3i minus 2i it becomes plus I. So therefore Z1 plus Z2 the whole bar it becomes 3 minus I. Okay, conjugate of Z1 plus Z2. Z1 plus Z2 it is 3 plus I. So therefore conjugate of Z1 plus Z2 it becomes 3 minus I. Okay, this is, you can give equation 1. Again Z1 plus Z1 bar plus Z2 bar. This becomes your Z1 it is 2 plus 3i. So Z1 bar it becomes 2 minus 3i. And then next, let me write it down. Since Z1 is equals to 2 plus 3i, so therefore Z1 bar is equals to 2 minus 3i. And again, since Z2 is equals to 1 minus 2i, Z2 bar is equals to 1 plus 2i. Understand? Now I will do Z1 bar plus Z2 bar. This is 2 minus 3i plus 1 plus 2i. So this becomes 2 minus 3i plus 1 plus 2i, 2 plus 1, 3, minus 2 plus 2i minus I. So this is equation 2. From equation 1 and equation 2, what did I get? Right hand side equal, minus 3i minus 3i equal. So left hand side I will get equal. So therefore I can write Z1 plus Z2 bar, it is equals to Z1 bar plus Z2 bar. This is your verified. These things are not so much hard. Rest of these problems you try to do by yourself. Okay, rest of these problems you try to do by yourself. I will go to next. I will go to question number 5 here. Question number 5, number A, saying that if Z1 is equals to 2 plus I and Z2 is equals to 1 minus 3i, then find z1 into z2 bar and z1 bar into z2, verify that these are conjugate of each other. Verify that these are conjugate of each other. So since z1 is equals to 2 plus I, therefore z1 bar, it will become 2 minus I. And since z2 is equals to 1 minus 3i, therefore z2 bar, it will is equals to 1 plus 3i. Now z1 into z2 bar, it becomes z1 is 2 plus I, z2 bar, it becomes 1 plus 3i. 2, 1 plus 3i plus I, 1 plus 3i. 2 plus 6i plus I plus 3i square. So 2 plus 7i minus 3 minus 1 plus 7i. Okay, this is our equation 1. And next I have to find z1 bar, z2. z1 bar, it is 2 minus I, and z2, it is 1 minus 3i. So 2 1 minus 3i minus I 1 minus 3i. So 2 minus 6i minus I plus 3i square. 2 minus 7i minus 3. So minus 1 minus 7i. This is z1 bar. Okay. This is our equation number 2. You see, equation 1, this is equation 1, it is minus 1 plus 7i, and this is minus 1 minus 7i. So this is a conjugate of this, and this is a conjugate of this. Understand? So therefore I can say from 1 and 2, it is clear then z1 into z2 bar is you can write z1 into z2 bar and z1 bar z2 are conjugate of each other, this one you can say. Understand? Next again number B, you see, for any two complex numbers z1 and z2, examine whether z1 into z2 bar and z1 into z2 are conjugate of each other. Again it is same. Let z1 is equals to x plus iy, and let z2 is equals to a plus ib. These two are complex number. So z1 bar, it becomes x minus iy, and z2 bar, it becomes a minus ib. So now z1 into z2 bar, this is x plus iy, this is x plus iy into z2 bar, a minus ib. So x a minus ib plus iy a minus ib. So this becomes x a minus ixb plus y a minus I square by. So this one, let me write ax, okay, ax minus I bx iay plus by. So this one I can write as ax plus by minus ibx plus iay. So ax plus by, this one I can do minus I common, so I will get bx minus ax, ay I will get, Okay, so this is the real part, this is the imaginary part. Okay, now next I will do again, this is our equation 1. Again I will do z1 bar into z2. So z1 bar it is x minus iy, and z2 it is a plus ib. Z2 it is a plus ib. A plus ib. So again x a plus ib minus iy a plus ib. So this one it becomes ax plus I bx minus I ay minus I square by. So this is ax plus I bx minus I ay. This becomes plus by. Okay, so this is again we can write here, you see the same thing again. I'm doing it in here. Again we can write it as ax plus by. Okay, ax plus by plus I bx minus I ay. So ax plus by plus I common, bx minus ay. This is our equation 2. So in here what I got, that z1 bar into z2, z1 bar into z2, this I got this. And now equation 1, you see z1 into z2 bar equation, this was equation 1. ax plus by, you see, look at nicely, ax plus by minus I bx minus ay, and this is what I got, ax plus by plus I, this is plus there and this is minus there, bx minus ay. So from equation 1 and 2 I can, from equation 1 and 2, from equation 1 and 2 it is clear, that z1 z2 bar and z1 bar z2 are conjugate, of each other, are conjugate of each other. Question number 6. If 2x is equals to minus 1 plus I root 3 and 2y is equals to minus 1 minus I root 3, then so that x square is equals to y. You see, if 2x is equal to this and 2y is equals to this, then I will have to show that x square it is equals to y. Okay, so 2x is equals to minus 1 plus I root 3. X will be minus 1 plus I root 3 by 2. X square it will be this I will get. So now Now next you see 2y is equals to minus 1 minus I root 3, it is given. So y is equals to, I will get minus 1 minus I root 3 by 2. And so in here if I put it inside, I will get ultimately minus 1 minus I root 3 by 2 only I will get. So therefore y is equals to x square. It is x square. You can give this as equation 1. So x square, it is how much? Minus 1 minus I root 3 by 2. So minus 1 minus I root 3 by 2, this is x square I can write. This is our proved. From equation 1. Okay. Next. So number 6, number 2, xy is equals to this is here, it is given. Now number 6, number 2, I have to show that xy is equals to a plus ib, where a is equals to 1, b is equals to 0. So in here 2x is equals to minus 1 plus I root 3. So x is equals to minus 1 I root 3 by 2. This is our equation 1. 2y is equals to minus 1 minus I root 3. So y is equals to minus root 3 by 2. This is equation number 2. Now 1 into 2 if I do, I will get xy is equals to minus 1 plus I root 3 by 2 into minus 1 minus I root 3 by 2. So this it will give me minus 1 plus I root 3 minus 1 minus I root 3 by 4. This is a plus b into a minus b form there. So a square minus b square by 4. This becomes 1 minus I square root 3 the whole square by 4. Minus I square, it will become plus 1. So 1 minus 3 by 4. Sorry, this will become plus 1. Okay, minus I square. This is minus 1. So plus 1 become. So 1 plus 3 it will become. So 4 by 4 is equals to 1. So therefore in here what I got, that xy is equals to 1 I got. Yes, xy is equals to 1 I got. So which I can write it as 1 plus I dot 0. So which I can write it as a plus ib, because in here a is 1 and b is 0. So this is showed. Understand? This one you can write it as 1 plus I dot 0, which is equals to a plus ib. Understand? Because it is given only, where a is equals to 1, b is equals to 0. So 1, I can write it in a plus ib form, which is 1 plus I dot 0. Now 1 is a, so a plus ib is 0, so a plus ib. This is xy is equals to a plus ib I show. Next I have to show number 3, that x is the multiplicative inverse. X is the multiplicative inverse of y and vice versa. X is the multiplicative inverse of y and vice versa. So solution, multiplicative inverse of y, this is equals to 1 by y. So y equals to 1 by let me do in this way. Multiplicative inverse of y, this is equals to 1 by y, which is equals to 1 by y, it is minus 1 minus I root 3 by 2 is equals to, I will get 2 by minus 1 minus I root 3. This is equals to, okay, not implies. So in here what I will do, minus 1 minus I root 3 minus 1 plus I root 3 minus 1 plus I root 3. So this becomes minus 2 plus twice I root 3 by, this becomes minus 1 square minus 1 root 3 the whole square. So minus 2 plus twice I root 3, this is 1 minus I square into 3. So this ultimately you will get minus 2 plus twice I root 3 by 1 plus 3 you will get. So minus 2 plus twice I root 3 by 4 I will get. So this you see, okay, minus 2 by 4 plus 2 I root 3 by 4. This you will get minus 1 by 2 plus I root 3 by 2 you will get. Or else let's do one thing in here. Let's do one thing in here. In here 2 I multiplied it. 2 I multiplied it with this one. You no need to do this multiplication. You keep 2 separate only. Okay. I have done it in here. So again what I have to do, again I have to common take in here. So simply I did multiplication. You no need to do the multiplication. Understand? This multiplication, this one, this multiplication, no need to do here. Keep 2 outside only. So this becomes minus 1 plus I root 3 by 2, which is equals to x. Yes, which is equals to x. So therefore I can say that 1 by y is equals to x. Understand? X is the multiplicative inverse of y and vice versa. Okay. So in here I show that I can write therefore x is the x is the multiplicative. Let me write down in here. So you see I got 1 by y is equals to x I got. So therefore I can say that x is the multiplicative inverse. X is the multiplicative inverse of y. I can say that x is the multiplicative inverse of y. Now again next I will do multiplicative inverse of x, that is equals to y I will have to show. Understand? Now multiplicative inverse of first I did y, now I will do x. Multiplicative inverse of x, it is equals to 1 by x, which is equals to 1 by x value, it is minus 1 plus I root 3 by 2, which I will get 2 by minus 1 plus I root 3. So this is 2 by minus 1 plus I root 3. I will multiply both sides by minus 1 minus I root 3, minus 1 minus I root 3. So this becomes 2, you no need to multiply, you keep it outside only. Minus 1 minus I root 3 by, this becomes minus 1 the whole square minus I root 3 the whole square. So 2 into minus 1 minus I root 3, 1 minus I square dot root 3 the whole square. So this becomes 2 minus 1 minus I root 3 by 1 plus 3. So 2 minus 1 minus I root 3 by 4 minus 1 minus I root 3 by 2, which is equals to y. So therefore I can say that 1 by x, this is equals to y. Therefore y is the multiplicative inverse of x. Y, this is what? It is 1 by x, and 1 by x is what? It is the multiplicative inverse of x. So therefore I can say y is the multiplicative inverse of x. This is our, first I did that x is the multiplicative inverse of y, and then I say that y is the multiplicative inverse of x. So this is our done. Understand? Next, the question number 7. So question number 7 here it is, solve the following. solve the following equations. So first it is given it to me that 3x plus 5y minus 4y is equals to 10 plus x minus 3y into y. So solution here. Three x plus 5y minus 4y 10 plus this it will become xi minus 3iy. Now you see this one I can write as 3x minus 4y. Real parts you bring it one side, minus 10 I will bring this side, and the imaginary numbers I will bring it to the other side. So this one xi minus 3iy minus 5i I will get. So this is oh sorry, no need to do in this way. Sorry. This one, first of all, you see 3x plus 5i minus 4y is equals to 10 plus x minus 3yi. So this is 3x minus 4y plus 5i is equals to 10 plus x minus 3yi. So this one, now what I will do, real part equate I will do, and imaginary part equal I will do. X minus 4y is equals to 10 and 5 is equals to x minus 3y. Understand? Real part equal, imaginary part equate I will do. Okay. So therefore in here two equations I got. 3x minus 4y is equals to 10, and below this you write, this is our 1, and below this you write x minus 3y is equals to 5. This is our equation number 2. Now I will have to eliminate whether x or y I will have to eliminate. X or y, either one of the variables I will have to eliminate. Okay, and I will have to find the other. So in order to do, I will multiply this by 1 and this by 3 I will do. So I will get 3x minus 4y is equals to 10. This is, you give equation number 3, and this it becomes 3x, 3 into x, 3x minus 3 into minus 3y minus 9y, 3 into 5 I will get 15. This is our equation 4. Now I will do 3 minus 4 I will do. So this minus plus minus become this, and this is gone. This becomes 5y is equals to 5. Minus 5, y is equals to minus 1. Now this y value I will put it in any one of the equation. So 3x minus 4y is equals to 10. You put the value of y here, minus 1. So 3x plus 4 is equals to 10. X is equals to 10 minus 4 by 3. So x is equals to, this becomes 6 by 3. It becomes x is equals to 2 becomes. Okay, x is equals to 2 and y is equals to 1. So let's check the back answer. Solve the following equation. X and y value I got. Now let's check the back answer. Exercise 2.2 number 7 number 1. Exercise 2.2 number 7 number 1, you see x is equals to 2, y is equals to minus 1. Understand? This is solving a linear equation, two linear equation. This is called solving two equations which have two variables and are linear by the method of elimination method. Okay, you will get in your general classes, this is how to do. You will get, now in here you remember, any one from this x and y, any one of the variables I will have to eliminate, and from that I will get the value of one variable, and this value of this variable I will have to put it in any one of the equations, and I will have to find the value of the other variable. Next it is, you see, next it is number 2. x plus iy plus 3 minus 2i is equals to 1 plus 4i. So in here solution, solve the following. Okay. Again, this is x plus iy plus 3 minus 2i is equals to 1 plus 4i. So real part you write it together. X plus 3 plus iy minus 2i is equals to 1 plus 4i. So this becomes x plus 3 plus I bracket y minus 2 is equals to 1 plus 4i. So now real part equal, imaginary part equal. So therefore I will get x plus 3 is equals to 1. This is your equation 1. And y minus 2 is equals to 4 I will get. Imaginary part equal. This is equation number 2 I will. So now in here you see, you write the okay. So in here you see x is equals to 1 minus 3 I will get. X is equals to minus 2 I will get. No need to do equation 1 and equation 2 in here. Again, y is equals to 4 plus 2 you will get. So y is equals to 6 I will get. So x is equals to minus 2, y is equals to 6. In here elimination method no need, because this is a linear equation in one variable. These two are linear equation in one variable. You see number 2, minus 2 and 6 it is there. Next again, your number 3, it is saying, number 3 you try to do by yourself. Let me go to question number 4. Okay, number 3 you try to do by yourself. Question number 4, it is said that 1 plus I x minus 2i by 3 plus I plus 2 minus 3i y plus I by 3 minus I is equals to 0 plus I dot 1. So solution. So this is, you see, one plus I x minus 2i by 3 plus I plus 2 minus 3i y plus I 3 minus I is equals to 0 plus I dot 1. So this one, x plus ix minus 2i by 3 plus I plus 2y minus 3iy plus I by 3 minus y is equals to 0 plus I dot 1. This is minus. Okay, so now let's take the LCM. 3 plus I, 3 minus I, x plus ix minus 2i into 3 minus I plus 2y minus 3iy plus I into 3 plus I is equals to 0 plus I dot 1. So from here I will get 3x plus 3ix minus 6i and minus ix minus I square x plus 2i square plus, again this I will get 6y minus 9iy plus 3i plus 2iy minus 3i square y plus I square. This one I am getting. By this it is a plus b into, so 9 minus I square I will get, and this is equals to 0 point I dot 1. Okay, this is equals to 0 point I dot 1. So this one again I will get here. This will become plus x. Okay, so let me write it again. 3x plus 3, this one you see 3ix minus ix, it becomes 2ix and plus 2. Again you see it is minus 6i plus x. This it will become plus x minus 2 plus this is your 6y minus 9iy plus 2iy, it becomes minus 7iy plus 3i. This it becomes plus 3y minus 1, this becomes minus 1 by 9 plus 1 is equals to 0 dot I plus 1. Oh sorry, this is equals to 0 plus I dot 1. Now you see the real part, 3x plus x, it becomes 4x. Then next plus this 4x, then again plus 6y plus 3y, it becomes plus 9y. Then minus 2 minus 1, it becomes minus 3. This is the real part. Now plus 2ix, this minus 6i plus 3i, it will become minus 3i. So let me write first of all plus 2ix minus 7iy minus 6i plus 3i minus 3i, and this it is gone, this and this it is gone, and the last again not there. So by 10 is equals to 0 plus I dot 1. Okay, 0, so 0 plus I dot 1. So this is again is equals to this denominator will split it, 4x plus 9y minus 10 minus 3 by 10 plus I common, okay, I common from here, 2x minus 7 by y minus 3 by 10 is equals to 0 plus I dot 1. So now real part equate imaginary part, I will equate it. Understand? So this I will have to rub here. This I will have to rub here. Okay, so real part equal 4x plus 9y minus 3 by 10. This is equals to 0. And then next 2x minus 7 by minus 3 by 10. This is equals to 1. Okay, real part equal, imaginary part equal. So 10 if I send that side, it will become 0 only. So 4x plus 9y is equals to 3. I will send that side. This is our equation number 1. And 10 I will send that side, then it will become 10. So 2x minus 7 by y is equals to 10 I will send this side and 3 I will send this side, then I will get 10, 13 I will get. This is our equation 2. So write this equation, these two equation in this way, 4x plus 9y is equals to 3, 2x minus 7y is equals to 13. This is equation 1, this is equation 2. Now I will use elimination method. Any one of the variable I will have to eliminate. So let's eliminate x. So this I will multiply it by 1 and this I will multiply it by 2. So implies that I will get 4x into 1 4x plus 9y into 1 plus 9y is equals to 3 into 1 3 only I will get. And this if I this whole equation if I multiply it by 2, I will get 2 into 2x, I will get 4x minus 14y is equals to 13 into 2, I will get 3 to the 6, 26 I will get 26. So this you give equation number 3 and this you give equation number 4. Now I will do equation 3 minus 4 I will do. So this becomes minus, this becomes plus and this becomes minus. So now this and this you can cut. 9y plus 14y you will get 15, 16, 17, 18, 19, 20, 21, 22, 23. 23y is equals to this you will get minus 23. Okay, minus 26 plus 3 minus 23. So y is equals to minus 1 you will get. Now this y value you put it in any one of the two equation. Putting putting the value of y in equation 3, if I put the value of y in equation 3, I will get 4x plus 9 into minus 1 is equals to 3. So this one I am directly doing here. X is equals to, you will get, this is minus 9. It becomes minus 9. That side go then. It will become plus 9. 3 plus 9, you will get 12. So 12 by 4 you will get, which is 3. So therefore what you got, x is equals to 3 you got, and y is equals to minus 1 you got. Let us check the back answer. Number 7, number 4 I have done. You see x is equals to 3 and y is equals to minus 1. Okay. So this is how we do. Next, question number 5 you try to do by yourself. Notes are already given it to you. You look at those notes and try to do by yourself. Next I will go to question number 8. Question number 8 saying if root over a plus ib, this is equals to x plus iy, then so that root over a minus ib, this is equals to x minus iy. So solution here, this is given that root over a minus ib, this is equals to x plus iy. If I square it both sides, I will get a minus ib is equals to x plus iy the whole square. A minus ib is equals to x square plus iy the whole square plus 2xiy. ib, sorry, this is plus. Okay, this is plus. So this I will get x square minus y square plus 2 xyi. So now what I will do, real part equate I will do. A is equal to x square minus y square, and imaginary part equal b is equals to 2xy. Okay. Now what I will do, now I will write a minus ib, I will write, okay, a minus ib, which becomes x square minus y square minus I 2xy. Okay. So is equals to this, I can write it as x square plus iy the whole square minus 2xiy. Okay, this it gives me x minus iy the whole square. So in here what I got, a minus ib is equals to this I got, taking square root both side, I get x minus iy the whole square. So this is equals to x minus iy. So square root of a minus ib, this is equals to x minus iy. This is our proved. Understand? This is our proved. Question number 9. If the conjugate of 2a plus ib is a plus 4 minus I, a plus 2b, then find the values of a and b. So question number 9. If the conjugate of 2a plus ib. So first of all, conjugate of 2a plus ib, this is equals to 2a minus ib, and by question I can say it is given that conjugate of 2a plus ib, this is equals to a plus 4 minus I a plus 2b. So conjugate of this is 2a minus ib is equals to a plus 4 minus I a plus 2b. Real part equate, and imaginary part I will equate to. So this gives me 2a minus a is equals to 4, a is equals to 4, and b is equals to a plus 2b. So b minus 2b is equals to a. So this gives me minus b is equals to a value, it is 4. So b is equals to minus 4 I will get. A is equals to 4, b is equals to minus 4. Let's check the back answer. A is equals to 4, b is equals to minus 4. Okay, next. Next you see question number 10. Question number 10. Find the additive and multiplicative inverses of the complex numbers. So minus 4 plus I, additive inverse of minus 4 plus I is minus 4 plus I, which is equals to 4 minus I, and multiplicative inverse of minus 4 plus I, it is equals to 1 by minus 4 plus I equals to minus 4 plus I minus 4 minus I minus 4 minus I minus 4 minus I by minus 4 the whole square minus I square minus 4 minus I 16 plus 1 minus 4 minus I by 17 minus 4 by 17 plus I minus 1 by 17. So this is the multiplicative inverse of minus 4 plus I. Let me check the back answer. You see 10 number 1 4 minus I, and next is minus 4 by 17 minus I 1 by 17, or you can write in this way also, 4 by 17 plus I minus 17 by minus 1 by 17. You can write in this way also. Okay, next one you try to do by yourself. 10 number 2, I think it is given in the notes. You try to do by yourself. If any problem, then you can ask me. Okay, let me show you number 2. It is given that 2 plus I 3 minus, first of all you can take this one, let z is equals to 2 plus I 3 minus 2i. You can do it. So this one you multiply to 3 minus 2i plus I 3 minus 2i. So this one you will get 6 minus 4i plus 3i minus 2i square. So this you will get 6 minus I, this one you will get plus 2. So 8 minus I you will get. So therefore minus z, which is the additive inverse of z, minus z, it will be minus 8 minus I. So minus 8 plus I. And 1 by z, this is equals to 1 by 8 minus I. So is equals to 1 into 8 plus I. 8 minus I into 8 plus I. So this becomes 8 plus I by 8 square minus I square. So this becomes 8 plus I. It is a 64 plus 1. So 8 plus I by 65. So 8 by 65 plus plus 1 by 65 I. This is the answer. Okay. 8 plus I is the additive inverse of 8 minus I, and this is 8 by 65 plus I 1 by 65. I 1 by 65 or 1 by 65 I, whatever you write. Understand? So next one, you see question number 11. Question number 11 saying that if Z1 and Z2 be any two complex numbers, then we can write that number A, RE Z1 Z2 is equals to RE Z1 RE Z2 minus IM Z1 into IM Z2. Okay, so first of all I will take that, let Z1 is equals to A plus IB and Z2 is equals to X plus IY. Let us take these two complex numbers. Okay, now we will do Z1 into Z2 we will do. So A plus IB into X plus IY. So this A X plus IY plus IB X plus IY. So this is AX plus IAY plus IBX plus I square BY. So AX plus IAY plus IBX minus BY. So AX minus BY plus IAY plus BX. This is Z1, Z2. Now RE Z1, Z2. Real part of Z1 into real part Z2 minus imaginary part of okay, so from here you see I can get that RE Z1 Z2, this will be is equals to AX minus BY. Okay, AX minus BY, and IM Z1 Z2 is equals to AY plus BX. Okay, from here this is the real part of Z1 Z2 and this is the imaginary part of Z1 Z2. So now I have to prove that RE Z1 Z2 is equal to RE Z1 and RE Z2. So now I will write since R1 is equals to, since Z1 is equals to A plus IB, therefore RE Z1 is equals to A and IM Z1 is equals to B. Again, since Z2 is equals to X plus IY, RE Z2 is equals to X and IM Z2, this is equals to Y. Understand? So therefore if I do RE Z1 into RE Z2, if I do RE Z1 into RE Z2, if I do, what I will get? RE Z1 is A, R2 Z, RE Z2 is X, so I will get AX. Okay, so this is RE Z1 is equals to A and RE Z2 is equals to X, so therefore RE Z1 into RE Z2 we will get AX, and then IM Z1 into IM Z2 is equals to, we will get BY. Yes, IM Z1 is equals to B, IM Z2 is equals to Y, so IM Z1 into IM Z2 we will get BY. Understand? So therefore if I do this RE Z1 RE Z2 minus IM Z1 IM Z2, I will get AX minus BY I will get. Yes, AX minus BY I will get. So AX plus BY, it is what? It is RE Z1 Z2, so is equals to, I can write RE Z1 Z2. So therefore I can write that RE Z1 Z2, this is equals to RE Z1 RE Z2 minus IM Z1 into IM Z2. This is your proved. Understand? I am explaining from the beginning. First of all, let Z1 is equals to A plus IB I will take, Z2 is equal to X plus IY I will take. I will multiply them, I will get this. So from here what I got? This is the real part and this is the imaginary part. Yes. So RE Z1 Z2, the real part of Z1 Z2, RE Z1 Z2, it is AX minus BY, and imaginary part of Z1 Z2, this is AY plus BX. So now Z1 is equals to, since Z1 is equals to A plus IB, so therefore RE Z1 will be A, real part of Z1 A, and imaginary part of Z1 will be B. And again Z2 is equals to X plus IY, therefore RE Z2 is equal to X and IM Z2 is equals to Y I will get. Now RE Z1 into RE Z2 if I do, I will get AX I will get, and IM Z1 into IM Z2 if I do, I will get BY. So this minus this if I do, RE Z1 RE Z2 minus IM Z1 IM Z2 if I do, I will get AX minus BY. So ax minus by is what? It is re z1 z2. So is equals to re z1 z2. So therefore I can write re z1 z2 is equals to re z1 re z2 minus im z1 im z2. Understand? And next one, like that you will have to prove. Next one, it is, you see, next one you see re z1 and im z2, this is equals to re z1. Re z1 is a and im z2 is y, so ay. And then again im z1 re z2 im z1, this is b, and re z2, this is x, bx I will get. So re z1 im z2 minus im z1 re z2, this is equals to ay minus bx. Yes, this is ay minus bx. Sorry, this is plus, in a plus given, so I will plus 2. Okay, plus I will do ay plus bx is what? Im z1 z2, so is equals to, you can write Im z1 z2. So therefore I can say that Im z1 z2, it is equals to re z1 Im z2 plus Im z1 re z2. Understand? So this is our done. Next it is 12th number I, saying that if p plus iq is equals to alpha plus I by alpha minus I, then show that alpha q plus alpha q is equals to 1 plus p. Okay. So solution, this is your given, p plus iq is equals to alpha plus I by alpha minus I. This is your given. So p plus iq is equals to alpha plus I, alpha plus I, alpha minus I, alpha minus I. Okay. So next I will get alpha plus I the whole square, alpha square minus I square, alpha square plus I square plus 2 I alpha I will get by, this is alpha square plus 1. So alpha square minus 1 plus 2I alpha by alpha square plus 1. So alpha square minus 1 by alpha square plus 1 plus I 2 alpha by alpha square plus 1. A plus IB form I am writing. Understand? So therefore I got that p plus iq, it is equals to alpha square minus 1 by alpha square plus 1 plus I 2 alpha by alpha square plus 1. So now real part equal, p is equals to alpha square plus 1 by alpha square plus 1 and q is equals to 2 alpha by alpha square plus 1. Okay. So now you see I have to prove that alpha q is equals to 1 plus p. So q is equals to 2 alpha by alpha square plus 1. So alpha q, it will be 2 alpha square by alpha square plus 1. So this is, I can write it as I have to 1 plus alpha square minus 1 I have to show. This one I can write it as alpha square plus alpha square plus 1. So this will be okay. Instead of doing this, I will take p is equals to alpha square minus 1 by alpha square plus 1. Both side I will add it. Okay, 1 I will add it. So minus 1 by alpha square plus 1 plus 1. Both side I will 1 I will add it. So p plus 1 is equals to alpha square plus 1 minus 1 plus alpha square plus 1 is equals to 2 alpha square by alpha square plus 1, which is equals to q, which is equals to this I can write it as alpha into 2 alpha by alpha square plus 1, so alpha into q. So therefore I can say that alpha q is equals to 1 plus p. This is our proved. Understand? 2 alpha square by alpha square plus 1, this one I can write as alpha into 2 alpha by alpha square plus 1. So 2 alpha, this one is a 2 alpha by alpha square plus 1, 2 alpha by alpha square plus 1, this is q, so alpha into q, so therefore p plus 1 is equals to alpha q, so therefore I can write alpha q is equals to 1 plus p. This is our proved. And the next, which is the last one, it is saying that if x plus iy is equals to a plus ib the whole square, then find the value of x square plus y square. Okay, find the value of x square plus y square. So in here it is x plus iy is equals to a plus ib the whole square, it is given. So x plus iy is equals to a square plus ib the whole square plus twice aib. So this is x plus iy is equals to a square minus b square plus twice aib. So x is equals to I will get a square minus b square, y is equals to I will get twice ab. So x square if I do a square minus b square the whole square, and y square if I do I will get 4a square b square. So now in here you see so this is x square plus y square is equals to I will get a square minus b square the whole square plus 4a square b square. This is a square the whole square plus b square the whole square minus twice a square b square plus 4a square b square, which is ultimately I will get a square the whole square b square the whole square plus twice a square b square I will get. Understand? So this is, you see, I can write this one as a square plus b square the whole square. So again what I will do, this will be the answer. Understand? Let me check the back answer here. X square plus y square I have to find. So x square plus y square I got, it is a square plus b square the whole square. Let me check the back answer. Exercise 2.212 number 2. Exercise 2.2 exercise 2.2 number 12 number 2, you say a square plus b square the whole square. This is only a square plus b square the whole square. Okay.